This is a brief tutorial on how to estimate sample size for Module 1. I will use the example study on chocolate intake and depression for this tutorial. I've just shown you how to estimate a sample size for a chi-square test. Let's change the predictor in our example to be a continuous variable. We are still estimating sample size for a cross-sectional study, and our outcome variable will still be depression, yes or no. But our primary predictor variable will be ounces of chocolate consumed each week. That means we need to find another test to use. Using Table 6.1 again, it tells us that the t-test is the appropriate simple statistical test to use to estimate sample size when we have a continuous predictor and a dichotomous outcome variable. Table 6a in your text is one possible way to estimate sample size for t-tests, but it only works if your populations with and without the outcome are of the same size. Therefore, we need to find another way to estimate sample sizes for our example. One possible approach would be to use the Rust Length app that we have online. This is what you will see when you click on the link provided on the other page. Right now, let's choose 2 sample t-test, pooled or Satterthwaite. This is what you will see when you first open it up. We'll see sigma, 1 and 2, N1, N2. There's a 2-tailed checkbox, alpha 0.05, which we'll always leave there unless you deliberately want a different one. And then an important one here is the true difference of the means, which I'll talk about more later. And then finally the power. In general, we'll always keep sigma at 1 for both sigma 1 and sigma 2. And you'll enter your effect size and the true difference of the means. Then we'll play around with N1 and N2 until we get the power that we want of 80%. But how do you know what effect size to use? First, can you find a similar study? If so, use the effect size they detected in their study. Second, you can use a standardized effect size. Page 67 of Hulley suggests that 0.2 is considered small, 0.5 is considered moderate, and 0.8 is considered large. Use these as general rules of thumb, but you should know that in some circumstances these might not be justifiable. However, choose a size and justify it and use it in your calculations. The final and most time-consuming option is to conduct a pilot study to estimate the possible effect size. Remember the limitations of the pilot study. Small studies yield unreliable estimates, and the pilot study may not always give you a good estimate for your larger study. I'm going to use the second option for this example, and I will assume a small effect size of 0.2 to be a reasonable estimate for my study. Therefore, I type in 0.2 in the true difference of the means. Again, remember that if you want to type rather than using the slider, you can just click on this bar and this box opens up. Then I begin playing with the numbers. I start with 1,000, and I assume that 10% of my population will have depression. 1,000 times 0.10 is 100, so I put that in N1. That leaves 900 to be in N2. The yielding power is 0.47, which is too low, so we'll need to try again. Next, I assume a total sample size of 2,000. N1 now becomes 200, N2 is 1,800, and our power is now closer to 80%, but not quite there, 0.76. So let's try again. This time, I'll assume a total sample size of 2,200. N1 now becomes 220, N2 is 1980, and the resulting power is 0.8032. That's close enough, and we'll stop here. So for a study with a continuous predictor variable, we estimate that we will need a total sample size of 2,200, assuming that 10% of our population will have the outcome and that the effect size is 0.2. Please don't be afraid to come and meet with me if you have any more questions about this. Also, in real life, always consult with a statistician to estimate sample size. The outlines I've provided here are very general and can help you get a rough estimate of your sample sizes. However, there may be better, more complicated ways to calculate sample size for your particular study. Thank you for listening to this tutorial.